Assalamualaikum warahmatullahi wabarakatuh. Hello everybody. Firstly, I'm very proud to share this video. Thank you for watching my video. Let me introduce myself. My name is Achmad Ghozali, an academic staff in Urban and Regional Planning Department in Institut Teknologi Kalimantan, Balikpapan. I deliver this video to present my research that I submitted to Science and Technology Research Symposium SiRes 2020, which organized by LPPM Universitas Islam Bandung. In this video, I will present my research result entitled Assessment of Surface Runoff Potential in the Klandasan Kecil Watershed, Balikpapan City, with 4 main sections: introduction, methodology, result and discussion, and conclusion. I hope you can enjoy this video and let me begin my presentation. First, introduction. In the period 2009 until 2015, the land use of residential area in Balikpapan city is about 13%. There were 44 land conversion activities, and since 2016, flooding has become an environmental priority issue in Balikpapan. The Klandasan Kecil watershed is one of the fastest growing area in Balikpapan city. So this is the main issue. The percentage of surface runoff was 80% in 2014 and is predicted to increase to be 90% in 2020. In the same period, build-up area in the Klandasan Kecil watershed area was dominant. So, in the same period, there is no inundation area in 2014, but in 2016, there is inundation area about 11 hectare. So the rainwater runoff occurs in high density built-up area is the issue, and the recent research on water management in urban area has found a new concept to heal this condition called water sensitive city. So, as first step to implement the concept, it is necessary to calculate the potential runoff in the Klandasan Kecil watershed Balikpapan. I begin with a literature study, the variable in the runoff assessment in the Klandasan Kecil watershed area to determine the surface runoff and the volume surface runoff and hydrological discharge. We found that this variable is the main variable to calculate the volume surface runoff to calculate the potential flood discharge. And then the research methodology. First, data and scope of the study. The region used in the research area was the Klandasan Kecil watershed region, which is rainwater catchment area. Primary data collection was obtained by means of a field survey regarding the condition and dimension of the drainage channel using a water pass device. In addition, secondary data was also needed to improve data analysis needs, and it consists of term data, land cover maps, and rainfall obtained from related government agencies. This is the map of the Klandasan watershed area. Klandasan Kecil, I mean, and then the second figure is about how the Klandasan Kecil area has the topography. And then the first stage, to measure the parameter and distribution of rainfall, determine the return period using the log percent type 3 distribution method. The next step is to calculate the planned inundation volume, which begins by calculating the surface runoff using the SCSCN or soil conservation service method. And then the final step is to calculate the hydrological discharge using the Nakayasu methods. Here, the formula to calculate it. And then Nakayasu hydrograph is divided into two parts, namely ascending and descending curve. In the ascending curve, the discharge is calculated by this equation, while the formulation on the descending curve is divided into three periods, namely the first period, second period, and the last period. And then how about the result of the study? First, the rainfall. The rainfall data used was the maximum daily rainfall data from the Balikpapan city station, namely Spingan Class 2 station in the period data 2009 until 2018 period, which can be seen as the following figure like this. And then we can see the figure that the maximum rainfall occurs in 2018, about 161. And then how about the land cover in Klandasan Kecil watershed? The extent and proportion of land use in the Klandasan Kecil watershed are present in table below. The domination about is the residence area is about 74%. And then this is the distribution of the land cover of residence, trade and service, military area, asphalt, industry, or the other land cover area. And the first analysis result analysis of the amount of surface runoff, we can see that the planned return period rainfall of 144 millimeter was used in accordance with the trend of the existing rainfall data. After obtaining the planned rainfall figure, then the calculation of the hydrological discharge in the study area is carried out in two stages. First, calculating the flow coefficient of the Klandasan Kecil watershed based on the land cover and calculating the design flood hydrograph using the Nakayasu method. In this table, we calculate the flow coefficient for each land cover, and the residence we can calculate that the residence area is about 422, and then the coefficient of C is 0.7, and then the flow coefficient around this. And then the hydrological discharge assessment using the Nakayasu method, we can divide it into three periods. First, the ascending period, and then descending period. And then this is the graph of the Nakayasu hydrograph. The time it takes from the onset of rain to obtain the maximum discharge is about 0.8 hours. The maximum hydrological discharge value is indicated by the discharge value at the peak point of the curve on the hydrograph with a value of 96 meter cubic per second. The unit hydrograph as in figure indicate that the time it takes from the onset of rain to obtain the maximum discharge is 1 hour. The maximum hydrological discharge value is indicated by the discharge value at the peak point of the curve on the hydrograph with a value of 1145 meter cubic per second, which then it decreases after 1 hour. And the second, the analysis of the storage volume capacity of the existing rivers, we can we use the sample of the dimension of the channel, the rivers I mean, about the 15 sample to calculate the dimension, and then we can calculate that the river only have capacity around 56 meter cubic per second. So the gap of the rainfall discharge and volume capacity of the river discharge, we can uh, we can calculate that the delta discharge is about 88 meter cubic per second. It means that the existing channel has not been able to accommodate all existing hydrological discharge, or there has been an overflow or flooding due to the inability of all runoff discharge to be flowed into the main river in the study area. And from the delta, we can calculate how many water in the area, in the study area. We can use this formula to calculate. First, we can calculate how about the rainfall duration each uh, rainfall occur. We can identify that the effective rainfall duration last is about 1.7 hours by considering the difference in runoff discharge that cannot be discharged by the existing river. It is found that the volume of rainwater that has the potential to flood in the current study area is about 550 meter cubic of water. So we can imagine how many water that will should be inundate the area. And then the conclusion. So first, the planned rainfall with a return period of 10 years in the area of the study is about 154 millimeter with a high enough rainfall. The peak hydrological discharge that occur in the study area, it reached to 145 meter cubic per second with a hydrograph peak time at 1 hour of rain. In addition, the effective rain duration that could potentially occur in the study area was 1.72 hours. The length and the second, the length of the river of the Klandasan Kecil was 3.8 kilometers with an average dimension of width and depth of 6.4 and 2.6. With this dimension, the hydrologic recharge that can be flowed by this river was only 56 meter cubic per second. So the third result, the result of the comparison of the hydraulic discharge and hydrological discharge in the study area indicate that there was a potential surface runoff that cannot be handled by the existing river of about 88 meter cubic per second, and it had the potential to become inundation in the study area. By considering the duration of effective rainfall and flood discharge, it can be estimated that the volume of runoff that cannot be accommodated by the river was 5,000 meter cubic. So this is my presentation. Thank you for watching. Wassalamualaikum warahmatullahi wabarakatuh.